Dear colleagues and guests, good afternoon. Let me declare open the session for the dissertation of Lapin, Ruslan, Leonidovich for the degree of Candidate of Physical Mathematical Sciences, Specialty 010204, Solid Mechanics, on the theme Calculation of Elastic and Strength Characteristics of Materials and Cracks. Due to technical reasons, let me announce a technical break. Let's resume our meeting of the Dissertation Council for the defense of thesis by Lapin, Ruslan, Leonidovich. According to the order, St. Petersburg University, dated the 12th of December, 2019, number 12274/1, me, Grekov Mikhail Alexandrovich, Doctor of Physical and Mathematical Sciences, Professor of the Department of Computational Methods and Continuum Mechanics of St. Petersburg University, was appointed chairman of this Dissertation Council. In accordance with the order St. Petersburg University of the 23rd of March 2020, number 2304/1, our meeting is held in the remote access mode, which includes my colleagues, members of the Council, and the applicant. Let me introduce my fellow Council members. Bauer Svetlana Mikhailovna, Doctor of Physical and Mathematical Sciences, Professor of the Department of Theoretical and Applied Mechanics at Petersburg University. Can you see and hear us, Svetlana Mikhailovna? Yes, I can. Can you hear us? Yes, I can hear you. Very well. Professor Altenbach Holm Johannes, Doctor of Technical Sciences, University of Honor von Horike, Germany. Can you hear us? Can you see us? Yes, I can both see you and hear you. Next. In the same communication channel we have Melnikov Boris Evgenovich, Doctor of Technical Sciences, Professor of the High School of Mechanics and Control Processes of St. Petersburg Polytechnic University of Peter the Great. Can you hear us? Yes, I can hear you and see you. That's good. Polyansky Vladimir Anatolievich, Doctor of Technical Sciences, Acting Director of the Institute of Mechanical Engineering of the Russian Academy of Sciences. Can you see and hear us? Yes, everything is okay. Same communication channel. We have the academic advisor of the applicant, corresponding member of the Russian Academy of Sciences, Professor of the Russian Academy of Sciences, Director of the High School of Theoretical Mechanics of St. Petersburg Polytechnic University of Peter the Great, Krivtsov Anton Miroslavovich. I can both hear and see you. That's excellent. And the applicant, Lapin Ruslan Leonidovich. Can you see and hear us? That's excellent. So all the members of the Dissertation Council, as well as the applicant and his academic supervisor, are in touch. We can all see and hear each other. Dear colleagues, since our meeting is being held in the remote access mode, I would like to warn you that the meeting can be accompanied by issues of technical nature. I invite all the participants to follow the procedure, and if you stop seeing or hearing someone, in case of technical failures, please inform me and I shall announce a technical break until these issues are eliminated. Let me also inform you that our meeting is being broadcast online and recorded at St. Petersburg University website, and the speeches are being simultaneously translated from Russian into English or from English into Russian. The applicant's page currently displays an email address to which you can send questions to the applicant regarding his thesis during the meeting, related to his thesis. These questions shall be forwarded to me and I shall read them out during the discussion. Questions should be related to the applicant's speech and the content of his thesis, and it's necessary to indicate the name, position and place of work of the sender. Questions not related to the scientific discussion, the discussion of the thesis, to the text and assessment of the thesis shall not be presented. According to the federal law of the 23rd of August 1996, number 127, on science and the state scientific and technical policy, St. Petersburg University has the right to award academic degrees independently. And the corresponding order on the procedure for awarding academic degrees at St. Petersburg University, on the basis of which we are holding this session of the Council, was issued on the 1st of September 2016, hereinafter the order, order number 6821/1. In accordance with this order, a session of the Dissertation Council is duly constituted if at least 2/3 of approved council members are participating, but not less than 4 persons. Our council consists of 5 members. Everyone is present, all in the remote interactive mode. Audiovisual contact has been established to all of them. Thus, we have the necessary quorum. I instruct the curator, the defense officer of the Dissertation Council, Activity Support Department, Karpov and Natalia Vladimirovna, to draw up the attendance list in which the Dissertation Council members and the applicant for the degree shall be included, and indicate their work mode, in this case remote. Let me set forth the procedure of today's session with the approximate duration of 2 hours, approximately. First, the chairman's summary report on the main content of documents submitted by the applicant and their compliance with applicable regulations. Answers to possible questions, approximately 5 minutes. Sound is off. I call a technical break.
Меня не слышно было или кого?
Вас слышно было.
А тогда у кого пропал звук?
Светлана Михайловна пропала.
У Светланы Михайловны? Так, Светлана Михайловна, как?
Нет, все нормально теперь, да. Загрузилась.
Нормально?
Да.
Так, технический перерыв заканчивается.
Let me resume. The technical break is over. Resume the meeting. Second, a brief presentation of the degree applicant outlining the key points of his research, approximately 15 minutes. Questions to the applicant, strictly on his report, no more than 2 minutes per question. Answers of the applicant, maximum 5 minutes for all questions. 5, speeches of all members of the Dissertation Council, with their opinions, questions and suggestions to the applicant, approximately 10 minutes for each speaker. A speech of the chairman, his review, approximately 10 minutes. 7, answers of the applicant to questions and remarks made by members of the Dissertation Council, no more than 5 minutes, but the applicant may also answer questions and comments after each review is presented. Well, I've mentioned that already. 8, open discussion. Speeches and questions to the applicant strictly on the topic of his research, no more than 5 minutes per each question. I shall also read out questions sent by the electronic mail, if any. 9, final answers of the applicant to questions asked, no more than 5 minutes. 10, a speech of the applicant's academic supervisor. 11, a 5-minute discussion before the open voting on awarding or not awarding the academic degree of St. Petersburg University to the applicant. For the time of this discussion of the council members, sound shall be switched off. Open individual voting. The chairman of the council shall count the votes and the results shall be recorded in the minutes of the meeting. 13, a decision on awarding or not awarding the St. Petersburg University academic degree to the applicant. 14, closing remarks of the applicant, no more than 2 minutes. Dear colleagues, does anyone have questions or objections to this procedure? If there are no questions or objections. Let's start the procedure. But before, let me remind you to switch off your mobile phones. Thank you for your understanding. Well, let's start the meeting, and our first item, the Chairman's summary report. A thesis by Lapin, Ruslan, Leonidovich for the degree of candidate of Physico-Mathematical Sciences, Specialization 010204 Solid Mechanics, on the theme Calculation of Elastic and Strength Characteristics of Materials with Cracks, was accepted for defense by the order of the Academic Secretary of St. Petersburg University on the 10th of December 2019, order number 12169/1. The Dissertation Council was appointed by the order of the Academic Secretary of St. Petersburg University on 12th of December 2019, 12274/1, and I have already, dear colleagues and guests, introduced its members. Lapin, Ruslan Leonidovich's thesis was written at St. Petersburg Polytechnical University. Academic supervisor, Doctor of Physical Mathematical Sciences, Director of High School of Theoretical Mechanics of Polytechnical University of Peter the Great, Anton Miroslavich. The number of publications of the applicant, which set out the main scientific results of his thesis according to the enclosed lists, is five scientific articles, including published in journals indexed in the scientific databases versus Scopus, 5 publications, peer-reviewed journals from the list approved by the Ministry of Education and Science of the Russian Federation, no publications. The applicant has submitted to the Academic Secretary of St. Petersburg University a full package of documents for acceptance, for consideration and defense. All the documents comply with Article 12 of Section 3 of the order. All the documents submitted by the applicant, according to the information I received from the curator, comply with the requirements and are kept in the applicant's attestation file. Copies of documents are available from the Office of the Dissertation Council Support Department. Curator of today's session, Karpova Natalia Vladimirovna, who's currently in touch with us. Dear members of the Dissertation Council, do you have questions regarding documents submitted? But do you want me to read the full list of documents submitted? No, that's okay. All the documents can be viewed if no one has any questions. So let us continue. Let's proceed to the next item: summary report of the applicant. Ruslan Leonidovich. Thank you very much, Mikhail Alexandrovich. Dear members of the Dissertation Council, the topic of my thesis is calculation of elastic strength characteristics of materials with cracks. My thesis consists of 4 parts in relevance and purpose of the work, 2 chapters, and a conclusion which sums up the results of presented for defense. The relevance is the influence of cracks on elastic and strength properties is relevant for modern science and industry. A large number of scientific groups under the guidance of leading scientists are engaged in this area of research, for yet existing results, analytical, numerical, and experimental results, unfortunately, leave open a number of problems about elastic and strength properties of cracked materials. The aim of my work is 4 objectives: to determine magnitude of influence of crack interaction on the elastic properties of materials, to determine dependence of components of pliability on the shape, size. Third, determine dependence of the crack energy of material with the fraction, and finally determine dependence of crack shape and quasi-static growth of properties of the 3-layer medium. First chapter is dedicated to effective elastic characteristics The first task was to determine effective elastic characteristics. The existing analytical approaches about properties have a number of limitations. Numerical methods cannot be applied in certain circumstances and can widen but choice of this or that method is not always obvious. Also should be the interaction of efficient elastic properties, materials with such materials with cracks. The question is, you cannot hear you well. Can you hear me better? Say something. No. You are too far from the microphone. We cannot hear you well. Okay. Let me continue. The question about the influence. We cannot hear you. That way it is better, so I will speak louder then. About the task. But elastic properties, a square sample with similar cracks as a flat deformed formulation. The cracks assumed to be similar, and location is random. Orientation and on the edges, the edges are free from loads. The material is linearly elastic. The location of this crack density concept is used, and decomposition is tensor of pliability is a sum of two tensors. As mentioned earlier, the magnitude of influence is determined using the has been shown was for any configuration of cracks in a material with has to evaluate deviation from sublimous tensor. Is assessment proposed in the article by Sebastianov and Kachanov 2008. To solve this task, used 10 of implemented the program of C++ to to reduce the influence of random arrangement of cracks, and approximation of 450 realizations was used. Used two families of cracks and three families of parallel cracks. For two parallels of parallel cracks, density is 2 times. To determine direction of orthotropic axis, a rotation matrix is used, and it's assumed that the deviation from orthorexy is minimal, shall be minimal. For the problem, direction of cracks, for obtaining Kachanov, is approaching the account shows that deviation does not exceed 5%. Estimation of orthotropic properties for all examined samples does not exceed 5%, and for effective sublimous tensor does not exceed 3%. May speak of orthotropic properties of similar calculations conducted for other installations or settings, and for all results the deviation from the axis with interaction does not exceed 5%, and orthotropy evaluation for in all densities, all settings, does not exceed 5%, and for average does not exceed 3%, which enables us to talk about orthotropic properties in the material with geometric symmetry. Next task considered in my thesis is the influence of links, as where cracks are not flat, and yet experiments and tomography show that links between the edges in real materials can have finite size and complicated shape. The study of this issue has been not well described, but others can work by Sayers 2009, published column type contacts as the influence of the shape of the contact and influence in three-dimensional setting. A linear elastic material with a crack is considered as a system of similar links, and the center of these links is in a square grid. And the edges of the crack and the edges of the links are free from load, from tension. Elastic. Next, if we assume that the size of cracks is much bigger than the size of the link, and if we assume that the greatest contribution to elasticity, suppleness is, then we may define and consider a cell of the periodical cell of single contact. As studied parameters, three unmeasurable units is responsible for distance and for the size of contact as height at h. When solving this task, we use the model implemented in COMSOL package, and the number of elements in our calculation was 2 in the 10th degree, as depending on shape of contact. Shape of contact influences this component greatly, and the transition in the case of flat contact is column shaped, is the shift component grows much faster. Also, in number, it's maybe interesting to consider the suppleness component obtained different sizes and of links. We show different results. For example, shape of contact influences relation of component, and starting with certain distance between contacts, reciprocal influence. And so also should be noted that shift in all cases is greater than normal. And the main results obtained in chapter 1 for crack material is in we haven't studied influence on orthotropic axis, and the direction or orthotropic axis can be obtained and studied the influence of orthotropic properties of materials, and orthotropic properties do not exceed 5%. The task of influence of link between the crack edges on suppleness, we obtained the following result. The form effect is quite obvious. It should be taken into consideration. The shift component is much greater than normal. And finally, when distance is big enough between the links, form is relatively independent. The second part is devoted to the problem of strength properties of materials with cracks. And the first task, I apologize, I can hear echo and it distracts me a little bit. So, shall we take a technical break? Does it distract you? Let's continue. We cannot. Yeah, now we can see you. All right. Well, so the first task in the second chapter was initiation of destruction of material with a single crack. And when considered initiation of destruction, is one of the most common approaches is to determine local fields. And however, some practical problems. It's important to determine the energy and fracture orientation. This issue has been poorly studied. Should mention article by Bratov-Krivtsov published recently, where the authors considered two-dimensional setup, and in the frame they used a complete three-dimensional setup. Set in the task, a periodic sample with a single crack is considered. Material is volumeric deformations are applied to the sample, and while the edges are considered free of load. Elastic and deformation energy in the material at the moment of fracture initiation is investigated. To solve this problem, we used a particle dynamics method, which was used in the C++ language. Material is a set of cracks, and destruction of material occurs when the springs are broken because of elongation, and cracks are presented as an array of destroyed springs, and a rectangular crack and a circular crack, and various loads were applied to shear, mixed, and compressive compression. The criteria of initiation was a number of broken springs by 5% from the initial number, and averaging on 5 implementations was used, and the number of particles in each calculation was about 4 in the 10�6th degree. The compared results with the results described in the article, and there's good quality coincidence characteristics, maximums and minimums, and in the crack orientation, and but the numeric deviations can be caused in this work and the work of Bratov and Krivtsov. For circular cracks, considered different profiles for different types of load, a different crack orientation, and results show that when we add a shear load, characteristic minimum and maximums, and in general the elastic energy decreases initially necessary to initiate fracture. Obtained results can be used for model of correct material. For that, we use several assumptions. As, similar circular cracks present in the material. The mutual impact can be neglected, and the orientation is random. And orientation, and this fracture will happen in a crack, orientation of which coincides with the profile of fracture energy shown earlier. For different types of loading, we obtained relations, and by adding small shear energy disrupts fracture energy, starting with certain values. Further increase of shear energy does not result in significant change or in the initiation energy. The second task in this was quasi-static development of a crack in a 3-layer medium. So this task is related in development of cracks in layered media, relevant for various industries, including oil and gas industry. There are many works which study elastic properties of layers and strength of layers, compression strength, but these works do not devote enough attention to the shape of cracks and how they changes as the parameters of layers change as quasi-static growth. I set the task as follows. 3-layer material was considered, central upper and bottom layers had similar properties. The central layer has a circular crack, and on the edges permanent pressure load is applied. Material is linearly elastic, and in our study we studied the influence of layers on characteristics of forms, which we understand as relation of length to height. As we when solving this task, we used model particle dynamic method, and which was earlier described. This model was implemented through a program in C++ language, and in the course of our study we studied how each parameter influences the shape of a crack separately. In the course of the study, the influence of strength layers, we found that for particular range of relations, strengths, we reach certain equilibrium state which is retained, and values greater exceeding this range, the shape of a crack and the crack itself remain in this central layer for range of values. When we reach permanent values, we approximated and we obtained a relation. The formula similar study was conducted for various elastic layers, and we obtained the relation, the form of a crack to relation of layers in the course of their development, throughout their development. We observed formula reaches permanent value, and the crack remains locked in the central layer for a range where Young models reaches constant value, and we obtained a relation of the shape parameters to Young modules. Similar studies were conducted for compressing loads in side layers. We obtained a range of values where the values reach constant level. We obtained a value starting with this. Layers remain locked in the central layer. For values in the range, approximation was conducted for 5 realization, and the main results of my thesis were by adding load significantly reduces energy necessary for to initiate fracture, and further increase of shear energy does not increase the destruction energy, and in the three-dimensional media obtained set of parameters where cracks in the course of their development retain constant value, and certain parameters, cracks, do not penetrate the side layers. The practical significance of our results obtained is proved by more technical solving practical issues, and results chapter 2 have been obtained with financial support from the Ministry of Science and Higher Education of the Russian Federation, through a federal special program. And in the course of my study, I published 6 articles in journals indexed by Scopus and Web of Science databases. The results put forth for production are presented on this slide. I shall not read them. Thank you for your attention, and I will be glad to answer your questions. Thank you. Thank you. Now, questions? Does anyone have, do council members have questions to the applicant? I have a question, if possible. All your Boris Sergeyevich, is that Boris Sergeyevich? No, this is Vladimir Anatolievich. Or Polyansky Vladimir Anatolievich is speaking. All the questions, all the results you obtained. There is no influence or development of the crack. I think this influence is there, which is proved by experiments. What error does your approach have compared to other approaches? How are they? In my study, we did not take into account how cracks influence each other, elastic effective characteristics. The growth of cracks we did not consider, but we took into account mutual influence of opening fields. And in the first chapter we did not consider growth of cracks. In the second chapter, the numerical results for cracked materials, the tasks were elastic deformation energy, and we used an assumption that cracks are quite far from each other and they do not influence each other, so the material is not heavily cracked. So we used an assumption, and how is the size of the crack, the length of the crack? What is far from each other? What do you mean by far from each other? Which distance is sufficient? We can run a number of tests, for example, in areas crack orientation, and observe tension fields. Will they be changed? Will there be any changes, and will the cracks influence each other, have any impact? So right now you cannot have an opinion. Is it like 1/2 of the length of the crack? So what is the what's the sufficient distance at which cracks do have no impact on each other? At the moment, the impact of cracks, I honestly consider the impact of cracks on each other, and starting with crack density, I think 0.2, 0.3, which the distance in that case is like half of the length of a crack, then there is impact. Thank you. I see. Thank you. More questions? Yes, I have a couple of questions. Welcome, Holm, Altenbach. My first question relates to relevance, which you describe in the beginning, and you say that there is influence, cracks on heterogeneity. Then there is a list of scientists who worked in this field, but I think of foreign groups you didn't mention many important studies. There are many other groups. Yes, Sevastianov, Kachalov, Kush work can also, who determines numerically of elastic properties for tasks many foreign scientists, sires for my task, for example. I think I named quite a lot of them, but my second question is this: the task about the crack or multiple cracks and the task of inclusion are very similar. How your assumption can be used in the tasks with inclusions, to solve problems with inclusions. If we talk, for example, in composite materials with particles, this is quite similar to your task with cracks. In one case there's nothing, in the other case we have something. Well, generally speaking, with some modification of the model, of course the model should be modified. Also, I have a question regarding slide number 9, where you showed density from 001 to 08. I agree with 001 because a technical material always contains cracks. But 008 seems to be too big to me. If we talk about fractured media, 0.7 maximum. In porous materials it can be 0 to 9/8, but because in your case cracks are very narrow, because of tension at the ends, it cannot be 0.8. Can you do you have any proof? No, the upper limit was obtained in heavily cracked material. We set ourselves the question of how cracks influence properties of material, and with greater density, impact of cracks increases. And we 0.7, so we limited ourselves to 0.8, and our numerical method can be used at such densities. So we may say that we have considered heavily cracked materials. I have two more questions. You have considered flat approximation in many situations, and orthotropic. You always have a question how a flat approximation is similar to reality. Analytically, results approximation have been obtained for three-dimensional material, if I remember, and in our study we considered a simpler setup, and during interaction in two-dimensional cases the impact is greater. Usually I agree, so this is easier, but evaluation will be more interesting to hear, to learn, if we obtain realistic results. And the third question is technical. Why you use tensors and sometimes you use matrix representations? A matrix representation, I have used matrix representation because I solve the problem numerically, and in numerical calculations I use the rotation matrix, and with matrix representation of the tensor for turn matrix. But do you agree that if you consider a physical object, a tensor representation is better? Yes, because matrix representation is linked to axis. Thank you very much. Thank you for your questions. Well, thank you. Do we have more questions? Seems no one has more questions. Then let us. I don't have questions, but I would like to add to Holm the flat task here is very realistic because orthotropy one axis is perpendicular to the plane. That is why cracks are considered as channel. They are not exactly flat, and then it's possible to in a flat approximation. This is a very interesting question. This is a very interesting question. This is a very interesting point. Here the real science starts. But because Ruslan Leonidovich did not answer your question, so I decided to add something to his answer. Let's move on to the next item of our agenda. As I understand, we don't have any external reviews. Since we don't have any external reviews, since all the reviews of all the members of the Dissertation Council have been published on the St. Petersburg University website, I suggest that the reviewers only focus on questions or comments to the applicant, but of course it's up to the reviewers. Then let us hear the reviews or comments, and first let us give the floor to Bauer Svetlana Mikhailovna. Please. I'd like to say that I make a very feminine start. I understand well a lot of work, but the presentation is terrible, and I have a feeling that Anton Miroslavich haven't seen your thesis, but such bad spelling mistakes and lexical mistakes. You criticized previous work, too many misprints, but when I saw your thesis, because everything is relative, someone who corrects and his name with mistakes. I have a feeling the Ruslan Leonidovich had no time, and translation was mechanical. I understand that the applicant has worked hard, and that is why I asked the applicant to send his published papers, because it's easier to read the English text. So this is my first comment, maybe to be taken into account. And same, I glad the author set forth, explained what he means by randomly located cracks, because he mentions randomly located cracks in his thesis, so it was not quite clear what he meant. About orthotropy, so we discussed, as we also have a question, so there is only one question. I asked already Ruslan Leonidovich this question when he refers to some experiments, so maybe I see. Svetlana Mikhailovna, can you hear us? Yes, I can hear you, but now we can see you again. There must be some issues with internet, so I would like, if it is possible, to explain to comment on this comparison with experimental data, because there is reference to works where this question was discussed. So that's all. But in general, I understand that the applicant has worked very hard, and it's nice. The work is written in 2 languages, because all the articles were published in English, and the English text has fewer mistakes. That's all I want to say. Thank you. Well, now please answer. Thank you, Svetlana Mikhailovna, for your comments. I absolutely agree with your comments, and so I accept So we cannot hear you very well. You're getting too far. I'm a little bit shy. Yes, my work contains a great number of misprints and errors. This is my mission. Thank you for noticing them. It is impossible not to notice them. Yeah, I understand, but thank you anyways. And as for randomly located cracks, in my presentation I tried to explain concerning the experiments. I can mention experiments conducted in Mechanobotechnica in material destruction, led by Weisberg, and with them on the qualitative level, when we discussed with the representative of the company, we obtained similar results of the impact of loading. So here is my result, my example of experimental data. Thank you. Svetlana Mikhailovna, do you have more questions? No. You okay with the answers? Yes, I am. Okay, next we'd like to give the floor to Professor Altenbach. I have two comments, and in general I like the thesis. My first comment is again technical, is about list of literature which is not presented in full accordance with the rules. And my second question is more important. I'm sure the applicant studied the literature and selected as one of the main models, the model suggested by Kachanov and Sevastianov. It's obviously in the list of literature there's a big discussion between different schools. On the one hand, it's nice that the applicant was not involved into this fight because he's too young for that. On the other hand, of course, it will be very interesting to hear his opinion, how this fight will finish, what will be the result of this fight. I see. Is that all? Well, please feel free to answer or not to answer this question. I don't know when this fight will end, but I hope that the correct theory will win over the fight, and in your doctoral thesis you can, after you do your doctoral thesis, you can get involved in this fight. So it will be interesting to learn about this this fight more. Yeah. Okay. Holm, is that all? So all you are okay with the answers? Yes. Thank you. Then let's give the floor to Vladimir Anatolovich. No. First we give the floor to Melnikov Boris Evgenovich. I have a list of speakers here. First of all, I'd like to comment on the relevance and practical significance, which are proved by documents that the results are already being used. So this is a good point. As for comments, first, can you speak up a little bit? Speaking of density of cracks, can you hear me? Boris Evgenovich, maybe you sit on this chair, just in front of the camera. Is this better? This is better? We'll see. Okay, so there was a question about the 0.8 density of cracks. Equality is not obvious properties. Values more greater than 1 is not obvious. So this is at these values there is a contradiction. The influence of the crack tip and plastic elastic deformation on the obtained results, the influence, that will be a promising future direction of research. Third, study of influence of jumpers between the crack edges on the components requires a more detailed transition or consideration of one jumper. 4. When solving the problem of initiation of fracture material, it's necessary to analyze the influence of crack sizes on the obtained results. But the author thinks this is not important. Also, I'd like to say that misprints, which jumps in the eye and makes it very hard to, but these comments do not diminish the importance of the work and the positive overall positive opinion, but it will be interesting to hear the applicant's answers. Thank you, Ruslan Leonidovich. Dear Boris Evgenievich, thank you for your comments. I will try to answer all your questions about crack density, greater than 1 and less than 1. When equals to 1, it will be very density will be very high. In my slide, I showed density 0.8 and 1, so the density will be greater, and so cracks will be closer to each other. And if the density is much greater than 1, so then is such density speaks of great number of tracks in the material, and so then this is not heavily cracked material, but sort of pieces of material. Over when the density is more than 1, such material should not be used. So solid, so this requires of so it depends on orientation of cracks and location of cracks. In my case, location was random, but of course orientation can also influence. Location may also influence. And parallel cracks in the material is much easier rather than inclined cracks, so that they do not intersect. And about the zone of elastic deformation zone, that will be an interesting subject to study. So this, well, as for transition from one jumper, in my presentation, I tried to describe this in more detail. And the main assumptions, the size of cracks is much greater than the size of jumpers. And so we believe that a main contribution is in the central part. As, in the edges, it's lower than the central part. And we cannot hear about the size of creases of cracks. There was a study for single cracks, and the size was selected so that this task matched and the edges had no impact. Opening of single crack was equal to monolith. And as for typos and misprints, I agree, I accept your comment. I will be more attentive in the future. Thank you very much. Well, Boris Evgenievich, are you okay with the answers? Are you satisfied? Well, yes, generally speaking, I am. Okay, that's good. Now let's give the floor to Vladimir Anatolyevich Polyamsky. Dear colleagues, I will skip some paragraphs of my review where I say that the work corresponds to I enjoyed reading. but I will very briefly describe the drawbacks, the shortcomings. For example, the qualitative calculation of parameters. So sometimes it's impossible to understand. It was impossible the Russian text. So the language of the thesis is sometimes bad. Also, there are two types of cracks, and so which contradict each other, and go down to a common definition of cracks. Important comments in the literature review, I think foreign authors were forgotten. Murakami, who's considered the patriarch of, and his book in 2012 is not mentioned, though it contains interesting results. And Semyonov, who also has interesting works, and this list, so you understand that cracks cannot be infinite. How correct, how accurate is the task, and with cracks they all have a limited depth. So this is a real scientific question I would like to discuss with you. That's all I had to say. But I think this is a good thesis, and I support awarding the degree. Thank you. Well, thank you, Leonidovich, for your comments. Let me say in Formula 29, I second degree was lost. The size depth should be in second degree divided by the area of studied sample. Is the length of crack. So density, when you have them in the second degree, that means your square is not, your cracks are not square but rectangular, have rectangular shape. The formula is widely used in literature for flat deformation, for flat setups, two-dimensional. It's widely used by many researchers. Elastic characteristics. I am satisfied with this answer, so let's focus on my main question. How will things change if we consider that cracks are have a limited depth? So if we move to three-dimensional setup, well, for example, Artyom Semyonov, he takes into account depth of cracks in flat setup, and this gives us, I agree with Holm, this gives us significant differences, yield significant differences. So should it be taken into consideration? Should we remember that cracks usually have ellipsoid shapes? So how your colleague looks, and elliptical shapes, some examples in his work. So how critical is your opinion about this? So it will be interesting. I think that in my setup, as I studied cracked material, studied the impact on certain characteristics in two-dimensional setup is even more important than in three-dimensional setup if we consider final. So my assumption is it will not change because the impact in the three-dimensional setup will be smaller than in the two-dimensional setup. And tension on the edges, don't you think it will have a significant impact when in each plane the number of cracks is the same when one crack finishes another crack starts? So finally you find yourself in a situation in most cross sections there will be cracks. So the impact of crack tips, if they are relatively close to one another, I think that will be a very significant factor that will significantly influence your formulas. Maybe I should clarify that components of suppleness tensor that we will obtain will change. So they will not coincide with those considered by me. I have considered already, but I'm looking at different characteristic of the suppleness tensor, its orthotropic properties, and these orthotropic properties. And if we solve the problem numerically and compare them to other components, and this orthotropic and non-orthotropic components and their relative value compared to other components will not change so much. The components of course will be changed because of orientation of cracks, and so I'm not saying that it will not change. I think the components will change significantly, but the orthotropic properties, in my opinion, will remain the same. And I think that's because the impact of in the two-dimensional setup is smaller than in the three-dimensional setup. Thank you. I am satisfied. I think that many, if you use non-local criteria, you mean in principle, yes, probably. That will eliminate many questions. Thank you. Thank you. Thank you. Is that all? Yes. Vladimir Anatolovich, yes, I said that my general impression is good, and I support the decision to award a degree. Finally, it's my turn to speak, and in general, I think this is interesting, and the author has described the tasks in the model he has chosen quite well, though of course the model has some limitation, for example, such as the fact that cracks should be far enough from each other so there is no impact, there's no influence on each other. So I liked the thesis in general, except for some presentation comments, but I also have a number of additional comments. Let me read them, not to waste too much time. My first comment: to solve the problem of effective modules, the author uses a method of boundary elements, which is directly related to the method of integral equations. In his thesis, feels the absence of integral equations, which became the basis for the method used by the author. Next, the term infinite crack, which is used in problem about the influence of jumpers on elastic characteristics of material, is incorrect. because in fact the author considers a finite cavity between half spaces connected by quasi-periodic system of jumpers. And I have never heard in the presentation that they have a quasi-periodic system of jumpers. Ruslan Leonidovich tried several times to answer my comment, and I think in the end the drawing doesn't show periodicity of these cracks and of these jumpers, location of cracks. There could be no periodicity, so it's better to do it. You see, you did it better in the article you covered with Kachanov's and infinite cavity connected with quasi jumpers. In that case, that description calls no questions. And for the point of mechanics is equals 0. If we do not introduce additional supposition, and the initiation energy is infinite, which can be seen from graphs on page 50 and 52, plotted in Novozilov's criterion. The picture is gone. I cannot see. I can no longer see two members of the council and of the academic supervisor. Okay, so the video is back. Can you hear us? Can you see us? And where is Holm? I'm here. I'm here. Okay, now I can see you. Well, that's good. From the point of if you use Novozilov's criterion, then initiation energy is infinite, but deformation criterion leads to finite values of this energy, and unfortunately there's no analysis of the destruction mechanism that occurs because of these loads. The thing is that in modeling, all the cells are connected with springs, and if the spring is extended, they can break eventually, and when they are compressed, then cells become compressed, so, and that should lead to destruction, material destruction. So let me continue. Let me continue, and then I would like Ruslan Leonidovich to explain this to me. 4. Figure the graph of dependence of density energy of initiation from the angular slope of circular crack to direction of an axial loading is asymmetric, 90 degrees, which is connected with an error in calculation. At the same time, this is similar graph for rectangular crack in figure 50 has a symmetry axis, which is probably due to an error, passes through the angle of 45 degrees. But that comment is connected with accuracy of calculations, with an error in presentation and a great number of misprints. 5. In the list of literature, some publications existing in Russian are given either in English or in translation. Suppleness tensor 35 coincides with a similar tensor for the case of flat deformation. Those are three-dimensional problem is considered. So these are all my comments. I think these comments should not and cannot affect the overall positive opinion, and the thesis corresponds to the requirements, applicable requirements set forth by the order of St. Petersburg University, and I believe the applicant deserves to be deserves the degree. That's all I have to say. Thank you. Ruslan Leonidovich, could you please? Thank you, Mikhail Alexandrovich. Thank you for your review. I will try to answer your comments now about the We cannot. Can you please speak in the microphone? Get closer to the microphone. The image is gone. Shall I continue? Yes. Speaking of integral equations, yes, it will be. Yeah, it would be good to include them in my thesis. As for the term infinite crack and the question regarding I agree, the main results are more is quasi-space connected by jumpers, but these results can also be applied to a big infinite crack. Maybe this is not correct, the voiding is not good, but anyways, this can be a large crack regarding the jumper size, and then results can be applied to such crack also. As for graphs, figures 50 and 52, indeed in figure 50 shows lack of symmetry, I agree. So this must be a numerical mistake, but as for a rectangular crack, have 45 and 90 degrees. Here I'd like to say that for a rectangular crack, the case of symmetry, if we look at figures 50-52, figure 50 for rectangular cracks is a part of figure 52, where in figure 50 you may see a parabol where the center of each corresponds to angle 45, and in the circular crack, because it is circular, it's the range shall be bigger, about 180, and maybe the representation of results was bad, but should put more emphasis on results and on that the axis range is different, but the graphs are correct. As for your other comments about misprints, as I mentioned, as I said already, I apologize and I will take them. And as for criteria, about criteria, I beg your pardon, yes, I missed this question. About criteria, in my opinion, that will be an interesting subject for future study. I see. Well, thank you very much. Okay, then let us, I have no comments to your answers, I'm quite satisfied. So let's proceed to the next item. Now I have to ask council members if maybe they have more good questions or comments to then let's give the floor to the academic supervisor, Krivtsov Anton Miroslavovich. The image is gone again. The three of you, the image sways for some reason. Shall we take a break? No, we are almost done. Let's finish. Dear colleagues, if we can all hear each other, we can continue. Anton Miroslavovich, please say something. I can hear Anton Miroslavovich, and I can hear Anton Miroslavovich. Me too. Okay, let's continue. Then let me start. Ruslan Leonidovich was our student of our department since his third year. He was involved in research. He was enrolled in a doctoral in the course, postgraduate, and Ruslan is the man who has great interest and who takes his work very seriously. And here I'd like to say I apologize for, here I would like to apologize for those misprints and mistakes in his work, but I'd like to draw your attention to how serious his approach is, and so maybe he doesn't pay enough attention to presentation. Because of that, we had some discussions, and we tried to eliminate this issue, but maybe not enough, and for which I apologize. But again, I would like to draw your attention to the fact that this is only true about the presentation, but as for the results described in his paper, Ruslan takes them very seriously, and everything has been tried many times. All the results have been tested many times, and in that sense, he's a very conscientious researcher. Next, I'd like to say that Ruslan works a lot alone with his research. He's involved in practical work, and the results described in his thesis result from his practical work as well. So here we have a combination of a young scientist who can also combine research with practical work and some assignments done for industrial companies. Ruslan took part in many conferences, various seminars, made many presentations, and in that sense he proved his mature researcher, independent researcher. So maybe at times he's even too independent, and sometimes he presented results before he showed them to me. But once again, he is very independent and conscientious scientist, researcher, and so I believe he deserves the degree and complies with the regulations. Thank you. Thank you. Next, I have a question. Since we are in the remote interactive mode, do members of the Dissertation Council or anyone present, or maybe the applicant, has any unanswered questions or connected with the online internet mode? No one has unanswered questions. Then, if no one has any remaining questions, then, dear colleagues, we have an opportunity before the final vote. We can take a technical break and have a discussion with the sound off. Yet, do you think such a technical break is necessary? No, we are fine. We don't need a break. Okay, then let us proceed to voting. Please make sure we can all hear each other. Yeah, the answer is yes. And I put the question of awarding to Lapin, Ruslan, Leonidovich the degree of Candidate of Physical Mathematical Sciences, Specialization 010204, Solid Mechanics, to the open individual vote. Let me remind you that the decision of the Dissertation Council on awarding the degree shall be considered positive if more than a half, but not less than 3 members of the Council present voted for it according to Article 3 of the procedure. Council member Bauer Svetlana Mikhailовna, your opinion for awarding the degree. Melnikov Boris Evgenovich, for. Palyansky Vladimir Anatolievich, for. Altenbach Holm Johannes, I'm for, yes. And me, Grekov Mikhail Alexandrovich, also for awarding the degree. Thus, dear colleagues and guests, let me announce that out of 5 members of the Dissertation Council participating, 5 voted for, no one voted against, and no one abstained. The decision to award to Lapin Ruslan Leonidovich the degree of Candidate of Physico-Mathematical Sciences, Specialty 010204, Solid Mechanics, has been made. Dear colleagues, since our meeting was held in the remote access mode, do the council members or the applicant or others have any questions, comments on the procedure of the meeting? No, we don't have any questions. Then let's give the floor to the applicant for his final word. Where's the applicant? Yes, I'm here. Dear members of the council, thank you very much. I would like to thank my academic supervisor, Anton Miroslavovich, for his support, for his guidance, for his advice. I would like to thank Kuskin Vitaly Andreevich, who also supported me actively. Scientific support, advice, and gave me some hints, valuable hints. Also, I'd like to mention all the members, to thank all the members of the Dissertation Council for reviewing my thesis, for reading it carefully, for their comments, and I will try to take them all into consideration and will not do the same mistakes again. Also, I would like to thank the organizers of this remote procedure, which made it possible regardless of the current situation. Thank you very much, everybody. Thank you for your participation. Thank you. Let me congratulate you, Ruslan Leonidovich, on being awarded the degree, and let me declare the session closed. Thank you. Goodbye. Hopefully it will be even more perfect next time.